So today's presentation is about earthquake hazards, or how can they be dangerous, and then what can you do to be safe in the event of an earthquake. What you need to do is take scratch notes as you view this presentation, which you will use to answer the questions on the notes check at the end. So earthquakes are hazardous in one of four ways, and you see them listed here. We're going to go through each one of them separately. First of all, seismic shaking is just what it is. It is the physical shaking of the ground when an earthquake releases energy. Now, the less sturdy the building you're in, the more likely it is to be damaged by shaking, because you get the ground shakes enough, it can cause your house to fall down. Now, unreinforced brick buildings are actually easily damaged by shaking. Loose soils, if the ground is very soft, it will magnify the effect of the shaking, and you're going to get a lot more damage. It's going to be a lot more hazardous. Whereas if you're on solid rock, not as bad. What actually kills the most people during an earthquake is when something falls on top of them. Either the entire building that they are in, or something inside the building they are in falls over and crushes them. Now, buildings made of brick actually shake apart very easily. Brick looks very solid, but the trick is with brick is very, very strong this way. That's why you can build brick high rises, and the bricks will stack up on one another and hold up a lot of weight. But brick is not very strong this way. You can actually knock a brick wall over pretty easy, and that's the way in which the ground shakes during an earthquake. So buildings that are made of brick actually aren't that strong during an earthquake. In places where they have a lot of earthquakes, they'll have signs on some of these buildings and say, hey, this is an unreinforced masonry building. Masonry is a word for brick or block. This is a building that is just made out of bricks or block. It is not safe to be in during an earthquake, and you can see what happens. The walls fall over very easily. If you're in the building, the wall falls on top of you, you could be killed. Concrete is also the same way. Concrete does not flex very well. It's very, very rigid. Now, it will hold up a lot of weight this way. It's very strong that direction. Concrete doesn't give very much moving that direction. So when you get an earthquake and it shakes side to side, concrete tends to break and crack and fall apart. Here are some older buildings in San Francisco in 1989 that were shaken apart and collapsed very easily during the earthquake in 1989. So where are you safe from damage by seismic shaking? Go outside, get away from any kind of building or anything that could be shaken and then come down on top of your head. In Japan, a place where they have a lot of earthquakes, they leave a lot of open spaces. It's a very crowded city, a lot of buildings, but they leave a lot of parks so that people can get out into the open and away from the buildings so that they're not killed when buildings come down on top of them during an earthquake. Now, your homes, especially in our area, a wooden house is actually much safer in an earthquake because wood can flex. Not like brick and concrete, which doesn't flex, doesn't bend. A wooden house will actually bend back and forth a little bit. So the houses that we live in here are actually a little bit safer from earthquakes. Now, inside your house, you should also kind of do the same thing that you did with a tornado, and that is go into a door frame, because you have a larger piece of wood over a door frame called a header. So it's a lot more stable, and it's a lot less likely to come down on top of you, and that's what kills you from seismic shaking in an earthquake. Now, it's not just the building itself, it's stuff inside the building. If you're in this library here and the earthquake comes on, the bookcases fall over on top of you, can kill you. So what can you do to minimize damage and then subsequent injury from seismic shaking? In places where they have a lot of earthquakes, Japan, California, New Zealand, they actually have to secure their furniture to the walls. Things like their refrigerators, their, in the old days, bigger, heavier television sets and bookcases and things. That way, when the ground shakes back and forth, your bookcase or your dresser doesn't fall over on top of you and kill you or trap you in the event of an earthquake. Now, in Japan, where they have a lot of earthquakes, they actually reinforce the buildings with metal frames. You can see them here. The advantage of metal is metal can bend. So this building here can shake back and forth, and it might be damaged and the walls crack and the bricks kind of get broken, but because it has a metal frame around it, the building doesn't collapse, and therefore it doesn't crush and kill people inside the building. You can see it here. These are in New Zealand. This hotel here that I stayed in had actually big hinges and big metal braces with hinges, so the building could move during an earthquake and it doesn't break and collapse and kill the people inside the building. Oakland, California. California has a lot of earthquakes. You'll see these big metal frames, and the metal allows a little bit more flexibility, and therefore the building can flex and it doesn't necessarily just break and crush and come down on people inside of it. Same concept here. We don't see this a lot in our parking garages here because we don't have a lot of earthquakes. In Japan, California, New Zealand, any place that gets a lot of earthquakes, you're going to see a lot more metal involved in building the buildings because that allows the building to flex when it's being shaken by an earthquake. Now, this is an older building in California, and older buildings that are made of brick will not flex very well. They will come down on an earthquake. So what they've done is they'll go back and they'll add these metal braces here, which adds a little bit of flexibility to the building. It will hold the brick in place so the brick just doesn't come down on top of whoever's in the building and kill them. Here's an old building in Hiroshima, Japan. It was an old museum. It was built of concrete. Concrete does not flex. It was built a long time ago. Well, now we know more about how to be safer from earthquakes, so they're going back and they're retrofitting this building to make it safer in the event of an earthquake. Here's an old school in Japan, and it was built before modern earthquake safety, and you can see they've gone back in and they've added metal bracing inside of the building to add some flexibility and add some support so that they get an earthquake, this school doesn't come down on the children inside and kill them. So liquefaction is when the ground becomes a liquid, because we know there's water deep down there under the ground, but an earthquake pushes the ground and it can actually push water to the surface. So ground that was dry, solid ground now becomes swampy, wet, soupy, becomes like a swamp. And if you have something built on that, well, it can't support its weight, and then you can get damage because of liquefaction. So you get something like this. You get water coming to the ground, and during an earthquake, the ground becomes liquefied and the building can't hold itself up, so then it falls over. If you're in the building, obviously, that's very hazardous and you can die. Notice this picture here in Japan. These apartment buildings, they weren't shaken apart. They did not break and fall into pieces. They actually literally just fell over because what happened was water came to the surface. Water was coming up to the surface and it made the ground underneath the buildings swampy, soupy, made it liquefied. Couldn't support the weight of the buildings fell over. Now, the question is, if you were in that building, did you die? Well, it depends. The building didn't kill you, but your refrigerator could have fallen on top of you. You could have gotten tossed around. If enough heavy things hit you, you certainly could have been hurt or even killed in this situation. Notice here, same concept. The buildings are intact. It's just that the ground underneath them become liquefied, so the buildings kind of slump over a little bit. Now, San Francisco, this is a huge concern in San Francisco because in the Bay Area, they have taken a lot of area around the bay that used to be wetlands and turned it into areas where they built houses. So the ground there is already wet. It used to look something like this here, and they reclaimed the land. They pumped the water out, made it a little bit drier, but there's still water deep under the ground. San Francisco is a very earthquake prone area, so a lot of water can get pushed to the surface, which means that the land can instantly become liquefied again, and therefore it's unstable, and you can have a lot of damage and subsequent injuries and deaths from liquefaction. Another big problem with that is things like your power lines and or your gas lines and your water lines are also under the ground. So as the water pushes it up to the surface, it can actually break the gas lines, which starts fires. It can break the water lines, which you need in order to put out the fires from the broken gas lines. You can see it here. This is what happened to a road because of liquefaction. Water was coming up to the surface and it pushed on the road and broke up the road. Now you also get landslides and mudslides because we know that materials on hillsides will like to slide. They will move down. And if the ground shakes a little bit because of an earthquake, that will cause things to flow downhill. So earthquakes are a huge cause of getting mud flows and landslides to start moving. So here's a case where they had a small earthquake in California. The earthquake itself wasn't so bad, not nearly enough to damage homes, but it had been raining and the hill was already muddy, and the earthquake shook the ground just enough that the mud came downhill and then went into this neighborhood, and that's what killed people. Now, a tsunami is a very special hazard unique to earthquakes. Now, and this happens when an earthquake happens underwater. And the energy from the earthquake pushes the water and makes a huge wave. And when that wave reaches shallow water, it becomes larger. And those large waves come onto the shore. That's the definition of what a tsunami is. It's a large wave caused by an earthquake pushing seawater. It's a Japanese term meaning harbor wave. Now, this is not a tidal wave. It's not caused by the tides. It's caused by an earthquake that happens over here. And the ground gets pushed up, and then that pushes the water up. And then that water's going to go somewhere. Something like this. Water gets pushed up in a bulge real quick, almost instantly, and then it starts to move out like that. And those waves are going to go somewhere, and they're going to hit the shore. Now, how far can they travel? You don't have to be right beside the earthquake. Tsunamis can travel the entire width of an ocean, thousands of miles. So sometimes you don't even know there was an earthquake. You didn't feel the earthquake, but the tsunami on the other side of the ocean is pushing water all the way across the ocean to where you are. This is the tsunami that was caused by an earthquake in Chile in 1960. And out here in Hawaii, they got hit with a tsunami. They didn't feel the earthquake. But there was an earthquake over here, and it pushed the water with such force that a huge wave came on shore in Hawaii and caused a lot of damage and killed people. Here's what it looked like. 6,000 miles away, the force of the water was enough to bend parking meters over. And parking meters don't catch a lot of water. It's a metal pole. So this shows you the power that you can have from when you get a huge wave caused by an earthquake hits the shore. Now, as long as we're on that subject, how big can they be? They can be up to 100 feet tall, but most are only about 10 feet high. And that's more than enough. A 10-foot high wall of water is going to knock down most wood frame houses. A concrete structure would probably be a lot safer, but most of the buildings we live in, that we shop in, that even that we work in, if they're low rise, are not going to be made of reinforced concrete, and they're going to get destroyed by a tsunami that's 10 feet high. How fast? They can go up to 500 miles an hour because there's that much energy from the push of an earthquake. That means they can go all the way across the Pacific Ocean in less than a day. In Hilo, Hawaii, they have been hit by tsunamis repeatedly over the years. And there's a tree there in a park right there in the harbor. And they put little signs on there that denote how high each tsunami wave was. And you can see my son over here in the picture for reference. And you can see here's a 8-foot one in 1957. In 1952, they had one that was 12 feet, 15 feet. They had a tsunami wave in 1948 that was 26 feet tall, and it basically leveled the entire town because there's very little structures that can stand up to a 26-foot tall wall of water. Here's actual footage from a tsunami in Japan in 2011, and this is not special effects. This is the actual water that was coming ashore from the earthquake-induced tsunami. This was a seawall that they had built here to help keep tsunami waters from coming into the town. It obviously wasn't enough for an earthquake of this size, and the town was destroyed when that wall of water came over. This is what it looked like. And you can see some of the big buildings that wound up on top of some of the buildings. It gives you an idea of how much water we're actually talking about. This is Indonesia in 2004, where a tsunami came ashore from an earthquake and just inundated most of the country. You can see some before and after pictures here. It even knocked down trees. These are two pictures taken from the same location, and you can see what the wall of water did to trees. And trees are stuck in the ground pretty tight, yet the tsunami totally flattened them. Now, to be safe from a tsunami, there's really only one thing you can do, and that is you have to get to high ground. Places that are in earthquake zones and hence tsunami zones will have warning systems. Very similar to how we have tornado sirens, they have tsunami sirens, and they go off, and when you hear that, that's an indication that there's been an earthquake somewhere and a tsunami wave might be coming to your location, and you're to leave and to go to high ground. They have little evacuation signs that tell you which way to go so that you get to some place that is higher than what an expected tsunami is going to be. Now, what we're doing now in the Pacific, especially after the Indonesian tsunami in 2004, they have buoys out there floating around out in the middle of the Pacific Ocean. And what these buoys do is they feel a rise in the ocean when a tsunami wave comes by, because you wouldn't necessarily see it. Out in the middle of the ocean where the water is deep, tsunami might only be a foot or two tall. But when it gets to shore, it might be 10, 20, 30, 40 feet tall. So they have these buoys out in the middle of the ocean that now are able to detect when they have a small rise from a wave caused by an earthquake. And they'll send a satellite signal up to satellites, which then sends a signal out to anybody who's in that area to be on the lookout for a tsunami. And what can we do now is we can send alerts to your phones. In this day and age, things like Amber Alerts and weather alerts that come up automatically on your phone. In the Pacific, they have a tsunami alarm system. Now, we wouldn't ever get this going off on our phone in Georgia because we don't live near a place, or we're not even on the coast, and we don't live near an ocean that has enough earthquakes in it to cause tsunamis. In Hilo, Hawaii, they've been hit by tsunamis so many times over the years, and the downtown has been destroyed multiple times, that they built this huge breakwater out in front. And notice this big, huge concrete, and this is meant to make a tsunami wave slow down. This is a breakwater, not for erosion. And you can see it's a lot bigger than most of the breakwaters we looked at for erosion. This is meant to help slow down the water from a tsunami wave, and therefore cause less damage and death. In Japan, almost every place along the coast, because they're in a very highly active earthquake area, they build seawalls. And they've stopped building necessarily right on the water because they know that's where the water is going to come when a tsunami comes in. So they build seawalls and they live on the other side of the wall. They also build floodgates. And if there's been an earthquake and they know a bunch of water might be coming from a tsunami, they can close off the rivers that are coming into the ocean, which doesn't allow extra water to go back up the river and cause damage. So now let's talk about where and when we're going to see these things. First of all, earthquake time or season. There is no such thing as earthquake season or time. It's not like tornadoes would happen mostly in the spring. It's not dependent upon the time of the year. They can happen any time of the day or any time of the year, which makes them especially dangerous because they can happen at night just as easily during the day, and you never know when one's going to occur. Now, how many of these do we get every year? There's about 500,000 earthquakes in the world every year. They are not rare. They happen all the time. There are earthquakes happening today somewhere in the world. They're not necessarily killing people, and maybe nobody even felt it, but there are earthquakes happening right now. How many do we get in the United States? About 20,000 every year. Once again, you don't hear about these on the news because most earthquakes that occur are small and don't cause damage. Now, where do they happen? If you look at this map here, this tells you or shows you or plots the major earthquakes from 1977 to 1992, and you'll notice it seems to kind of follow a pattern. They're kind of like seem to be kind of in a line here, and we've seen these shapes before because they match the shape of the tectonic plates, and that's exactly where earthquakes tend to happen. Earthquakes tend to happen at plate boundaries because that's where the plates are touching one another and pushing on each other and squeezing those rocks that then break and release energy. So you can have an earthquake that's away from a plate, but they are a lot more common at plate boundaries. And that's how we're going to describe where earthquakes happen. Generally at plate boundaries. And the more active or the faster moving the plate, the more earthquakes you're going to have. Now, in the United States, our most active plate boundary is that Pacific plate where it hits the North American plate, which is this right here, which means that's where we get a lot more earthquakes occurring in the U.S. We get a lot more earthquakes in the West than we do in the East. Notice very few earthquakes in the East because we're not at a plate boundary. Now, what state in the West gets the most earthquakes? The number one earthquake state in the USA is Alaska. Most people would say California. California is famous for its earthquakes, but Alaska gets by far a lot more earthquakes than California. So why do we always associate California with earthquakes? The difference with Alaska is Alaska's a big state, and you might have an earthquake that happens out here and nobody lives there. So nobody felt it, and it doesn't do any damage. So it doesn't make the news. But there's earthquakes happening right now in Alaska today. In California, that San Andreas Fault runs right there. And it runs from San Diego to LA to San Francisco. Millions and millions and millions and millions and millions of people live right along the San Andreas Fault in California. So even a small earthquake in California is big news because a lot of people feel it, and they call the news and say, hey, we had an earthquake today. And it makes the news. An earthquake in California does a lot more damage than it does in Alaska because there's more stuff to damage in California. So the number one state for earthquakes in the U.S. is Alaska. They have more earthquakes than any other state, but California has more damaging earthquakes because there's more people there and more stuff to get damaged. Now, do we have earthquakes in Georgia? Yes, we have earthquakes in Georgia. The largest one to ever occur in Georgia was in 1914. It had a magnitude of 4.5. And that's a pretty small earthquake. In Georgia, that would have been big news in 1914 because we don't get a lot of earthquakes. A 4.5 in California, yeah, people probably wouldn't even blink an eye at it. But in Georgia, that's our world record most powerful earthquake ever in Georgia. In the town of Madison, there were some reports of some damage to buildings, some cracked foundations, things like that. But it wasn't a huge, damage and destructive in terms of earthquake. Now, we've only had 50 earthquakes in the state that have a magnitude of 2.5 or greater. So the conclusion with Georgia is we do have earthquakes, but they don't happen very often. And all of the quakes that we tend to have are really small. And rarely are they felt by many people. Now, the strongest earthquake ever in the United States happened in Alaska. Happened in 1964 on Good Friday, and it was a magnitude 9.2. Remember, the strongest one ever in Georgia was a 4.5. So just looking at those numbers, you would say, oh, the one in Alaska is over double the power. That's not really the case here because every increase in 1 is an increase of 100 in terms of the power of the earthquake. So a magnitude 5 is 100 times more powerful than a magnitude 4. So this magnitude 9 is tremendously more powerful than anything we've even come close to experiencing in Georgia. There was some good luck with this Good Friday earthquake that happened on a Good Friday, which was a holiday, happened during the day. So people were at home, they were in their houses, happened at 5 o'clock in the afternoon where people were awake and not in their beds. So very few people died from the strongest earthquake ever in the United States because of when it happened and on the day it happened. If that earthquake had happened in the middle of the night, or it happened when people were at work and they were in concrete buildings instead of wood buildings that they live in, the deaths would have been a lot higher. Now, the strongest earthquake in history was in Chile in May 1960. This is the one that's in the huge tsunami that wiped out Hilo, Hawaii, and it was a magnitude 9.5. So you can see it's almost just a little bit more powerful than the one that we had in Alaska in 1964. Now, the world's deadliest earthquakes. Up to 242,000 people have been killed in a single earthquake in China in 1976. If we look at these, we don't see the United States on here at all because the United States doesn't tend to have a lot of earthquake deaths. China, the one that really sticks out is Haiti because it happened in 2010. The one in Indonesia in 2004, that was directly the result of the tsunami. It wasn't the earthquake itself, it was the tsunami that came ashore. So earthquakes kill people, and they can kill a lot of people. Let's look at the deadliest U.S. earthquakes. 2000. In 1906, the San Francisco earthquake killed 2,000 people. The next deadliest one was in Alaska. It killed 165 people. So in the United States, we don't tend to have as many deaths from earthquakes as they do in other parts of the world. And there's a reason for that. In other parts of the world, people live in substandard housing. This is in South America. This is in the Caribbean, where in 2010, Haiti had over 200,000 people killed. They lived in these not very well built buildings. So when the ground shook on this steep hillside, these buildings collapsed, and that's what killed people. In Japan, in the United States, even better, more so in China, the Philippines, A little bit more modern countries, the houses are built better, so you're not killed when your house comes down on top of you. So, some conclusions about earthquake deaths. Fewer people now die from earthquakes, and more people die in poorer countries because they live in buildings that get destroyed quicker by earthquakes. This time, come see me with your notes. Take the notes check.